what I'm going to do is show you one last combination of symmetries. I'm not going to take scale and point. I'm going to take point and line. There's a little exercise that goes with that. And then I want you to see if you can come up with your own kind of symmetry, right? What can you invent? Right, okay. So we've got this one, scale plus point. What happens when you do scale plus line? Well, I'm going to construct it in a particular way, okay? So right now, I want you to leave off on your square, on your rosy looking thing, okay? Finish that off another time. Underneath it though, I want you to draw a right angled triangle, but not just any right angled triangle. It's going to have these exact proportions. 1, 2, so I want this other side to be twice as long, okay? Now that makes the hypotenuse how long? Pythagoras, square root of? Root 5, right? If you put the 2 up here, this one will be the square root of 3, but as it is, the hypotenuse is the square root of 5. Oh, no, that's it. Okay? So it's a 1, 2, square root of 5 triangle, okay? Now, when you've drawn that, okay, you probably will draw it in this orientation. That will make it nice and easy, okay? But once you do draw a nice decent size, I want you to rotate your page so that the hypotenuse is lying flat along the bottom, okay? You don't have to, but it'll be easier for you. Now, since I can't rotate my whiteboard, I'm just going to redraw this, okay? Same triangle, but in a different orientation. So you rotate your page, but I'm going to have something like this. 1, 2, square root of 5. Okay.
So we draw the thing first.
Okay. So you draw it normally, and then you can you have the luxury of being able to rotate your book, but unfortunately I cannot. So here's my same one, and I've just turned it around. Okay. Now we're going to divide this up in an unusual way that takes advantage of scale and line symmetry. Okay. I wonder if you can see where this comes in. Okay. The first thing you're going to do is see this point up here, the one with the right angle in it. Okay. We're going to drop down an altitude. Do you remember what an altitude is? It's going to be, it's how high it is, so it's perpendicular to the base. And that's calling this the base is very helpful, okay? So I've got this line coming down like so. Okay? Alright, so there's my first division. I'm gonna do a few more, okay? Gotta make sure I do it right. Take this side of length 2, that we've called 2, right? And let's bisect it. So I'm gonna have this here. Okay, that's about halfway. Then I want you to also bisect this side here. See how I've divided this up? So you have the hypotenuse. I've got the left part of the hypotenuse and the right part. Okay. This left part, the longer part, I want you to bisect this as well. Something like that. Okay. So this distance and this distance will be the same. Okay. So far so good? Now you did 2 bisections. Okay. I want you to join up those 2 midpoints like so. Now you might be able to see it on mine. You should be able to see it even better on yours. What do you notice about this line you just drawn? That's parallel. The altitude and this line, whatever it is, right? Parallel. Okay. All right, now, those 2 parallel lines, I want you to join up with a perpendicular line like this. Okay, it goes across like that. So from the side of length 2 over to the hypotenuse, from side 2 over to the hypotenuse. And then our last join, okay, is I'm going to go from this side 2 again to the base or the foot of the altitude. Okay. Now what have we just made? Okay, have a look at this. You can clearly see there's a lot of reflectional symmetry in here, right? Can you see the line symmetry? For instance, I can see some line symmetry here, right? I can see some line symmetry here. There are other kinds of symmetry that you can see, right? I know mine looks a bit squarey here, but yours should be quite rectangular, okay? Right, now, here's the challenge I want to set to you, okay? You started with the 1 and the 2 and the square root of 5, okay? But now, we've introduced all of these other subdivided sides, okay? Now my question to you is, you've all constructed it in the same way. So all our triangles should be the same. What are the lengths that have resulted? What's that length? How about this one? What about this one? Now I want you to have a go, okay? You know enough geometry to work out all of these lengths. Taking the original values and knowing carefully how we constructed this triangle, okay? So what I'm going to ask you to do is try and work out what these lengths are. I've just picked out these two, but you can pick some other ones, right? What are those lengths? And once you've found them, what's interesting about them? Okay, so give that a go. I love this because we transition from, you know, like in your normal class, you're like, okay, I'll work out this length because the question says find X or something like that. But here's just a puzzling scenario, right? And you're just like, I want to know stuff just because it seems weird and interesting, right? Other things like, I'm going to put some labels on here, not because the question says there are labels, but I struggle to describe this adequately without being able to say this is A, and this is B, and this is C. People have been struggling to say, oh, you know, this corner, and then you turn it around, and that language, right? If you don't have real labels, it's very, very difficult. Okay? Last thing I'm going to call this P. Right, now some of you, most of you have noticed, similar triangles are going to be very important. Okay, now you can do it in a few different ways. Let me show you one way. Okay, have a look at, I'm going to put ABC, the big triangle, I'm going to put it up on its side. Okay, so there's the right angle. The right angle I've matched up to A, I'm calling this B, and this is C. So BC is my hypotenuse. Okay, so I've got square root 5, 1, 2. No problems? Okay, now I'm interested in some of these lengths. For instance, what is this altitude? That was one of the first questions I got asked. So I'm going to compare that to this smaller triangle. It's APB on mine. Okay, now they're similar. How can you tell they're similar? I know they look like it, but how can you tell? Yeah.
One of the angles.
Good. Yes, I have a common angle. Which one?
Angle.
Yes. Well, the 90 degree is not common. They're equal. That's good. But I need one other angle. I think it's going to be this one, right?
Oh, sorry, I was looking at the wrong triangle.
That's all right. That angle is in the small triangle and it's in the big triangle. And you can even see them here, right? So therefore, I'm going to say this. ABC is similar to PBA if you match up the vertices, right? And the reason is equiangular. Good. Okay, I just showed you those two angles, right? Now, therefore, I can say things about the ratios of the sides. Okay, I can say things about the ratios of the sides. For instance, have a look. What kinds of interesting things can you see here? This is 1 over here, right? So I can put a 1 here, right? So that means with all of these lengths, right? For instance, this side, BP, over this side, AB, right? This side to this side, small to big, should be the same as small to big, right? Don't pack up. Let's finish this. Right? Well, AB is just 1. So BP is just, that's BP on 1. And this is 1 on root 5, isn't it? 1 on root 5? 1 on root 5. You can play the game again and you'll get 2 on root 5 here. Right? Now, if you keep on going all the way throughout this triangle, what you'll notice is that, well, this triangle is similar to the big one, because we saw it. Well, guess what? Every other triangle is also similar. Right? So we have just divided up this triangle into 5 triangles that are congruent to each other and similar to the big one. Okay? You ready for your brain to melt? You can keep doing this. You can make them bigger. There's one that way, there's one this way, there's one over here, and then there will be one more here. This big black triangle, I created 5 triangles that are now the size of the original one, right? But it's what is this? It's scale symmetry. Okay? It's also line symmetry because so many things are reflected.